Knowledge of predator-prey interactions can help to resolve conflicts between wildlife and man and improve our understanding of the potential effects of top predator declines on communities. However, our understanding of species interactions involving top predators in the marine environment is limited due to their wide-ranging and relatively inaccessible nature. So each year since 2009, we've been using a relatively new acoustic biologger called the Vemco Mobile Transceiver, or VMT, to look at encounters between grey seals and Atlantic cod. So the VMT is an acoustic transceiver. It sends out an acoustic code to identify itself and also records detections from other acoustic transmitters that are within several hundred meters of it. So by deploying VMTs on grey seals and acoustic transmitters in Atlantic cod, we can begin to examine the interactions between these two species to determine whether or not they share the same habitat and the importance of Atlantic cod in the grey seal diet. The VMT is an archival instrument, which means that if you want your data back, you have to recover the tag and recapture your animal. So this has limited our deployments to Sable Island, where the chances of recapturing animals is actually quite high. But it creates a bias in your sampling area so that you can't explore other areas, for example the Gulf of St. Lawrence, where grey seal predation on cod is thought to be more important. In this study, we tested the development of a Bluetooth link between the VMT and an Argos satellite transmitter to determine whether encounter data can be remotely retrieved through Argos and allow deployments to occur in areas where the chance of recovery is low or on species where recapture is not possible. In October 2012, 2 adult female grey seals were captured on Sable Island and fitted with a Bluetooth-enabled GPS satellite relay data logger and VMT. In June of the same year, through a concurrent study, 17 grey seals were tagged on Sable Island with non-Bluetooth GPS satellite tags and VMTs in a manner similar to what is described here. Through collaboration with the Fisheries and Oceans Canada, 600 Atlantic cod had active acoustic transmitting tags in the area where the 2 female grey seals were likely to travel through.
So my name's Tim Stone. I'm a director in R&D and I helped design the VMT. Yeah, so the VMT, it's connected on the seal as well as the satellite tags. Satellite tags more to the head of the seal. And they're out there and he's listening for fish tags as he's moving around on this seal. And he collects a bunch of data. And then when the seal hauls out of the water, the satellite relay device has a water switch on it. It then knows it's out of the water, so it starts looking for a connection to the VMT, which has a Bluetooth. He's cycling his Bluetooth on, they make a connection, and then the satellite tag offloads all the data from the VMT into his own memory. So we compress the data in the VMT because we have a limited payload in the Argos link. We have 32 bytes to work with, and a good part of that is already used up by what the satellite tag needs. So we have to take all of this information, diagnostics information, remove it down and get it down to just detections. Once we've done that, we pass it to the satellite unit and it again reduces it. It looks at a known list of IDs. Instead of passing a 5-byte fish identifier, it reduces that to an index, which is a single byte. Also, with the number of encounters, if we have 100 different detections for the same fish, we can reduce that down to a single record with a count of 100, so we know it was 100 times for that fish.
In January of the following year, when the 2 seals returned to Sable Island to breed, they were captured and their instruments removed. The data were downloaded and a comparison was made between the detection data archived in the tag and that which was transmitted via the Argos satellite system. When we looked at the data that we got from the archival tag and the data we got from the Bluetooth tag via Argos, we found that the data were actually very similar. The only difference were 2 detections that were missing from the transmitted data. So this means that the Bluetooth tag has provided us the same behavioural information as the archival tag with a full archival data set. So we have demonstrated that a Bluetooth link can be used to exchange data between two physically separate telemetry units on a free-ranging marine mammal. So the configuration of using Bluetooth and Argos means that we no longer need to be concerned about recovering the tag to get our data back. So we can deploy these tags in areas where the chances of recapturing our animal is very low. For example, the Gulf of St. Lawrence. So that removes our bias in sampling. But it also means that these tags could be used on other species that spend very little time on land or all of their time out at sea, for example sharks and sea turtles. The use of marine animals such as seals as bioprobes extends our capability of collecting valuable physical and biological data from remote areas that may be otherwise inaccessible or too costly for sampling. Such data can contribute toward improving oceanographic models for predicting the effects of climate change and on resolving conflicts between top marine predators and man.